All right, welcome back. So today, we're going to dive into something really cool, a potential breakthrough in how we train AI. We're talking about a shift from teaching machines to just copy us to actually teaching them how to think.
Look, we've all seen AI agents that are amazing at following a plan, right? They can execute a whole sequence of commands, step by step, flawlessly. But what happens when something goes wrong? You know, when the plan doesn't work out or the world isn't exactly how it expected. That's the real test, and that's the core question we're tackling today. So, to really get why this new solution is such a big deal, we've got to understand the problem it's trying to solve. It's what researchers call the AI imitation trap, and it's a huge hurdle in building agents that are genuinely smart.
Now, for a long time, the go-to method for training these agents has been something called imitation learning. The best way to think about it is like a student driver who's only been taught to memorize one perfect route to one destination. They can copy every single turn, every stop, exactly like their instructor showed them. They learn what to do, but they have absolutely no clue why they're doing it.
And that's where the trap springs shut. What happens when there's a road closure on that one memorized route? Well, that student driver is completely lost. They don't have any real common sense for navigating. They can't reason about their mistake and figure out a new path. In an AI trained on pure imitation, it does the exact same thing. It just gets stuck.
So, right? That's the big question. How do you teach an AI to handle that unexpected detour? Well, the breakthrough idea here is to completely flip the script. Shift from learning by copying to learning by judging. You know, people have tried to fix this before. Earlier methods were kind of like giving that student driver a pre-written script that explains why each turn was a good one. But you see the problem, right? The AI is still just copying. It's memorizing the words for why, but it's not actually understanding it. And this is where agentic critical training, or ACT, just completely changes the game. Instead of handing the AI a script, it gives it a choice. It shows the AI two different possible actions and basically asks, hey, which one of these is better? And it only gets a reward if it makes the right judgment. This forces it to build its own internal logic, its own reasoning. It's like putting that student driver in a simulator where they get points for making smart, safe choices. This slide just lays it out perfectly, right? On one side, you've basically got an actor reciting lines. It looks intelligent, but it's just imitation. On the other, with ACT, you have something that's genuinely thinking for itself, born from having to make choices. It's the difference between faking it and actually getting it.
Okay, so this all sounds fantastic in theory, but how does it actually work? Let's pop the hood and take a look at the actual training process.
It's really a three-stage pipeline. First, you build your training data. For every good action an expert makes, you have the model come up with a slightly worse alternative. Step 2. That's the agentic critical training we just talked about. You use reinforcement learning to train the model to always pick the better option of the two. And then finally, you take this new, smarter, more critical model and fine-tune it to actually go out and perform its tasks. And this diagram really helps visualize the whole thing. You start with that expert data, then you create these choice scenarios in stage 2 to build the model's reasoning muscles. And then in stage 3, you let that new, more thoughtful model loose on the original tasks. The end result is an AI with a much stronger foundation for making good decisions.
Okay, the whole pipeline is pretty clever. But here's the million-dollar question. Does it actually work? Does it create a better AI agent when the rubber meets the road? Let's check out the results.
The numbers don't lie. Across 3 really challenging test environments, adding ACT into the training process gave a consistent boost in performance. We're talking about an average improvement in success rate of over 4.6 percentage points. Now that might not sound huge, but in the world of AI, that's a really solid, consistent bump.
But you know, stats are one thing. To really feel the difference this makes, we need a story. So let's look at a tale of 2 agents, both given the exact same task.
So here's the setup. It's a simple task. An AI needs to clean a spoon and then put it on the dining table. It does the first part just fine. It cleans the spoon at the sink. But then it tries to put the spoon on the table, but here's the catch. It tries to do this while it's still standing at the sink. Obviously, that's not going to work. So what does the standard agent do, the one trained with just imitation? It gets stuck in this ridiculous loop. It tries the failed action and fails. So it tries it again and fails. It literally repeats the exact same mistake for more than 30 steps. It's basically banging its head against a digital wall because it has no clue why it's failing. But then, you get the ACT-trained agent, and after a couple of tries, something incredible happens. It has this little aha moment. It generates this internal thought, this self-correction. It actually reasons, wait a minute, I'm at the sink. I can't put something on the table from here. I need to go to the table first.
And that is the power of ACT right there. The agent uses that critical thinking it learned to analyze its own plan, figure out what went wrong, and then come up with a brand new correct action. It walks over to the table, places the spoon, and boom, task successful. It didn't just blindly follow instructions, it actually solved a problem.
Now, this ability to self-correct is already super impressive, but honestly, the most mind-bending part of this whole thing is what comes next.
So get this. The researchers took their agent, which, remember, was only ever trained on stuff like cleaning spoons and moving things around a house, and they decided to throw it a massive curveball. They tested it on something totally new, completely outside of what it was trained on.
And we're not talking about more chores. They gave it heavy-duty stuff, complex math problems from the Math 500 benchmark, graduate-level scientific reasoning questions from GPQA Diamond. These are tasks that have absolutely nothing to do with navigating a virtual kitchen. And the result? It was just, wow. The ACT-trained agent performed significantly better on these general reasoning tests than the agents trained without ACT. Let that sink in for a second. Training an AI to choose between Go to Sink and Open Cabinet somehow made it better at math and science.
So what does this all mean? The big takeaway here is that ACT didn't just teach the AI a new trick. It seems to have fundamentally improved its core ability to reason. And that suggests that teaching an AI to be critical about small, specific things in one area could be a way to unlock a more general, flexible intelligence that works everywhere.
And that leaves us with this huge, fascinating question. If an AI can pick up a general skill like reasoning from very, very specific training, it kind of changes what it even means to teach a machine. Maybe we don't need to teach it everything under the sun. Maybe we just need to teach it how to think. And that, well, that could change everything.